Yes.
Oh, number 48.
All right. 48. Oh, all right. So it's one of these. So it's one of these where you have to identify the population sample, parameter, statistic, variable data. Oh, right. We did a couple. Political pollsters may be interested in the proportion of people who will vote for a particular cause. That one. I don't want to do this problem for you, but
I just had a question on the parameter.
Okay.
That I can get. It was just the parameter. I was a little confused on it.
so what is a parameter or a statistic? They are either normally what or what? No. Parameter describes a population numerically. A statistic describes a sample numerically. Describes it in what way? Specifically, there are two main things they could be. I could take data and I could find the average, or I could find a percentage. Which another word for percentage is proportion. So obviously, which situation is this? They're interested in the proportion of people. So the parameter's got to have that word in it. So the parameter would be the proportion of all voters or whatever your population is that you said, right? And then the statistic would be the same exact wording, except you would talk about your sample. Is everybody with me? It's really that straightforward, right? A parameter and a statistic are numerical descriptions of population or a sample. So they're going to sound the same. One talks about everybody, the other one talks about subgroup. Not that evil, believe it or not. Okay, I like it. Anything else from homework stuff? Yes? Oh, yeah. 1-4 is my little gift to you. It's your reading assignment, really, just to get you used to reading through a section. There's a lot of definitions in 1-4. So the first problem in the 1-4 homework is just using the terminology correctly. So you have to read it. Yeah. Okay. So I'll take specific questions after more people have done that. Yes?
If there's no homework assignment for one of the sections, do you still need us to read it?
Like which one are we talking about?
1, 6, 7, 8, 6, 7.
Oh, yeah, no. What was 1? 1-6 is not really it's actually kind of like a problem. It's a little sampling experiment thing. So it's another thing that you could do in class or for homework if I wanted to make you do it. So no. Maybe we should look at it. Nothing wrong with that. Anything else from homework? Everybody understands homework. You have homework assignment. I love it when it's like 2 weeks in and somebody's like, we have homework? We have to turn in? I didn't know. Holy shit. Everybody's aware. You know how to find it. Everybody has found it, right? And everybody has started doing it. Because you're all smart people. Yay. Okay. All right. Yes?
In 16A and B, like, you know how the field, the relative frequency always adds up to 1? Is there ever, like, a situation where it won't add up to 1, and then, like...
Yeah, totally.
And then that'll be an error, I guess?
No, won't be an error. I mean, all right. If you round your percentages, will they add up to 1 necessarily?
Not exactly.
No, because sometimes you'll round up more often than down just because that's how the numbers are.
Yeah.
Right? But if you add up the relative frequencies and you get 0.95,
Yeah.
that's way too far off. I'd say you should be within 1%
Okay.
at most, yeah. If you get 95%, you left somebody out.
Yeah.
Yeah. 5% of your population is missing. This is bad, right? The rapture happened. You're still here. Shit. No. I'll take your car if it happens. It's fine. Thanks. This ain't going in. All right. Anything else? That was deep all of a sudden. Random religious deepness. Okay. All right. So, what I want to do, I got a couple of things to finish up from 1. Then I've got a little handout. Now, the whole thing about the frequency charts, when we get into chapter 2, I mean, there are problems in chapter 1, but it should be pretty straightforward, I'm hoping. We'll talk about those more in conjunction with chapter 2. Because chapter 2 is going to take those tables and convert them into these things called histograms, like the bar graph kind of stuff. So that's going to be a big focus of today is how to construct histograms. Yeah?
One thing I wanted to know, like, okay, so yesterday we were on chapter 1, today we're in chapter 2. I mean, like, are we doing chapter per day?
Pretty much.
Okay.
Yeah. Not totally. Sometimes there's chapters with way too much information, so, but you can pretty much see how I broke it out.
Yeah.
Yeah. I put tentative time frame because those might change depending on what's happening. Okay, everybody okay? Any other homework questions? Specific, general? Specific, general? Okay, so let's do this. The last few things from chapter 1, there's only a couple of definitions we haven't done that I want to talk about. I'm leaving 1-4 up to you guys. Is the difference between discrete and continuous. Continuous is sort of like a little bit easier to start with. So you should all know what continuous kind of means. Well, what does it mean? What's continuous mean? Just keeps going. It doesn't stop. It doesn't skip. Now, it might stop, to be honest. Right? So continuous is kind of like it can take on any value between two values. So how heavy could a backpack weigh? Depending on what you put into it. So if it's an empty backpack, it's not 0 pounds, right? It's like maybe quarter of a pound, whatever. Like quarter pound or half. You guys, everybody with me? So maybe like a weight of a backpack would be anywhere from a quarter of a pound up to the most you could put in there before it's not a backpack anymore because it falls apart. Are you with me? I have no idea what the capacity is for a backpack. Let's just pretend like it's 40 pounds. So how heavy could it be? Could be 40 pounds, right? Could be 11.1276539 pounds, right? Now, if I ask you guys, another example would be how far away do you live? If I ask you how far away you live, somebody tell me about how far away do you live from the college? About?
5 miles.
5 miles. Do you really live exactly 5 miles away? Whoever said that? I mean like exactly 5. That would be really amazing. You probably live like 5.17629 miles. So you guys are pretty with me. Those are examples of continuous data points, continuous variables, because they can take on any value between two values. So either you live on the college and security hasn't found you yet, right? You're like under something, you're like, you know. I remember I had friends that lived at the university and would shower in the nuclear building's emergency shower, because that's the life of a grad student. But, so you live 0 miles away, up to whatever is the maximum commute you can make. You take your private jet in from 500 miles away, whatever. You guys, everybody with me? So, could it only be 12 and then 13? Wouldn't that be a little weird? You have to be able to have any distance between two. So, discrete would be the other way around. So this would be stuff like backpack weight, distance from school. So as a human, I would say I live about 5 miles away. But is it exactly 5? No, it's probably 4.9876. You guys with me? So that's continuous. It doesn't skip values. Now, if I ask you, how many doors do you have on your car? And you say to me, 3.765 doors. What the shit's that? What? One of the doors phases in and out of existence. It's not here right now. Come on now, you with me? So discrete is that it skips possible data values. Right? So if I said, how many TVs do you have in your house? You can only say 0, 1, 2. Are you with me? You wouldn't say 3.5 because one of them works half the time. It's a freaking TV. I didn't ask if it worked. So how many TVs do you have in your house? Would be discrete. Because you can't say you have 3.854 TVs. You guys with me? So continuous basically means if it makes sense to say 11.3896645 forever, it's continuous. Right? Discrete, that kind of thing doesn't make sense. Now, are there any cars or trucks that have like what's called a half a door? Does that make it discrete just because it has a decimal? No. Because you still would be able to say, I got 2 doors, 2.5 doors, 3 doors. Am I skipping values? How many values are between 2 and 2.5? There you go. An infinite number. 2.00001, 2.00002, 2.000. Okay, I'm not going to do them. That would take forever, literally. So discrete is stuff you can actually count. I can count the number of doors. I can count the number of TVs. I cannot count the number of possible weights of a backpack. You guys with me? So this is countable. Maybe. So be really careful. If I said, so here's a question I like to ask. All right? Discrete or continuous? I live 5 miles from the college.
Discrete.
Continuous. I don't want to make the person that said discrete feel bad, but don't look at the 5 and say it's a whole number. It's discrete. That is not what discrete means. Did it say discrete means whole number? No. I said discrete would be things that skip values. This one, do you have to skip? Do you have to live 5 miles away and then there's like nothing? And then things exist at 6 miles and then there's a void. And then 7 miles, they exist again. Holy shit. No, they exist. Everything exists forever, continuously, right? Your house could be a little bit further, a little bit further, a little bit further, a little bit further away. So don't look at the number. Think about the variable. Right? Yes.
There's always like a minimum and maximum for continuous.
For most things there would be, because we're talking about stuff we can measure and observe. There could be some theoretical thing that can go to infinity. I mean, time could theoretically go to infinity, right? But we don't know for sure. Okay, maybe. Or you guys are like, what a morning, man. What is it? We're already what? And we're talking about freaking infinite time and shit. Not too horrible, not too horrible. So what I want to do is I'm going to give you a little practice sheet from chapter 1. And then we'll talk about it. I officially call it group work. So if you want to group up with people, if you really don't, you could be a little army of one, that's fine. But I'd rather you work with other people. Okay? So let me get you started on this little dude here. It's very similar to the way I would do quiz questions, by the way.
Professor, you'd have to see a pink calculator.
Sorry, buddy.
That's okay.
Let me check up here. I don't know if there's anybody else in this room. Normally they find something, they put it under the podium up here. I lost count. Let's see what happens.
I may have left it at my house.
Huh?
It's either I left it here or at my house.
Oh, okay.